Hello, class. In this example, I have a case 1 for the method of trying to solve one of these Cauchy-Euler equations, like the one I have here. X squared times the second derivative of y with respect to x minus 2x times the first derivative of y with respect to x minus 4y is equal to 0. So for us to actually solve this, we're going to let y be equal to x to the m power. So y prime will be m times x to the m minus 1, and y double prime will be m times m minus 1 times x to the m minus 2 power, which could then be used to pop into our differential equation. So this being a homogeneous equation in our case, x squared times the second derivative of y with respect to x minus 2x times the derivative of y with respect to x minus 4y would then be equal to x squared times m minus 1 times x to the m minus 2 minus 2x times m times x to the m minus 1 minus 4 times x to the m power. So multiplying this out and whatnot, and then, well, combining the x terms specifically in all this is going to make m times m minus 1 times x to the m power minus 2xm times x to the m power minus 4 times x to the m power. We could factor out an x to the m times m minus 1 minus 2m minus 4. And we could simplify an inside by multiplying by the m, combining the negative 1m minus 2m. This will make x to the m power times m squared minus 3m minus 4. That's supposed to be equal to 0. X to the m power is not 0, so the m squared minus 3m minus 4 needs to be 0. And that's going to factor to be m plus 1 times m minus 4. So if that equal to 0, we get two distinct real roots, negative 1 and positive 4. So our general solution is going to be y is equal to c sub 1 times x to the negative first power plus c sub 2 times x to the fourth power, based on this example. So let me know if you have any questions or concerns. Thank you.